Now that we've got a better understanding about how fiber optic gyros work and some of the applications they're used for, we talked to Jay Napoli, who's the Vice President of Fiber Optic Gyro Sales at KVH. He's going to help us determine which product is right for you.
At KVH, we produce a wide range of fiber optic gyros that fit almost every customer need, particularly when it comes to stabilization, pointing, and navigation solutions. What makes our gyros unique is they offer a great deal of value for the performance that they provide. The DSP 3000, DSP 1500, DSP 4000, whatever your particular gyro needs are, single, dual, or three-axis configuration, the KVH fiber optic gyro products offer excellent performance and extremely long life. Long life of a gyro is important in terms of life cycle system cost. Whatever you want the gyro to go into, you don't want to have to replace that gyro in a year or 2 years or even 5 or 10 years. You want it there for an extremely long time, and you want it to provide the performance that you need so that your system operates properly. So KVH fiber optic gyros is particularly the inertial measurement unit products such as the TG6000, the CG5100, and even the CNS 5000 can be used in a lot of different applications. One in particular that comes to mind is oil and gas exploration. So that encompasses everything from the dynamic positioning of the vessel on the surface to underwater vehicles that go down and perform various tasks in terms of maybe building something underwater or orienting and positioning something underwater. You have to remember that the gyros measure very, very accurately motion in certain axes. And this is important, especially underwater, because there is no GPS signal available, which could be used in a lot of land applications. Another example of an application where KVH fiber optic gyros are used is a weapons simulator called the Javelin Basic Skills Trainer. The Javelin is a shoulder-fired or tripod-mounted or even vehicle-mounted rocket system, sort of like a bazooka. The problem with doing that is to train the soldier costs quite a bit of money. So the Army developed a simulator wherein the soldier puts the weapon system on his shoulder, and as he moves, he looks through an eyepiece. He sees actual imagery, digital imagery in the eyepiece, and the gyros measure the motion as the soldier tracks the target. So he learns the weapon system in a simulation environment that's very, very realistic without having to actually send a $100,000 or $200,000 rocket or missile downrange. So what we're demonstrating here today is the DSP 1500 single-axis sensor. Again, this is the sensor portion of the gyro, processing and power electronics. This whole other thing is really a safety system so that I don't damage my gyro in this demonstration. What we're going to do is show you the rate output, meaning how fast the gyro is measuring the input that I give it, or how accurately it's measuring it, as well as the absolute angle. I'm going to reset the angle back to 0 so that you can see that when the gyro is stationary, as it is right now, nothing is happening. As soon as I move this container tray and rotate it, you will see both the rate move and the absolute angle move. So I'm going to first rotate it in a clockwise direction very slowly, and you can see that the output that it's giving to the program shows that I'm moving it at a relatively constant rate of about 10 degrees per second. I can give it a much higher input rate back and forth, and you can see the corresponding output on the screen from the input that I give to the gyro. Another output that you're capable of getting from the gyro is the angle, the absolute angle of movement itself. So if we call this the 0 orientation and I rotate the gyro 90 degrees, which is approximately there, I don't have a calibrated eyeball, so I can't tell exactly if I've moved 90 degrees. But you can see, I'm sorry, I just bumped the gyro, so the gyro responded and gave the output. But if I rotate the gyro 90 degrees, as you can see, the angle will move corresponding to the input that I give it.